Hello, geometry folks, and welcome to Areas of Trapezoids, Rhombuses, and Kites. Today you're going to need your notes, calculator, a pen or a pencil, and your formula sheet. And we are going to get started working with more figures and their areas and how they're used. So let's start off by talking about the height of a trapezoid. The height of a trapezoid has to be found by making that perpendicular 90-degree drop down. So there's lots of places that we can drop a 90-degree angle and find the height of a trapezoid. The area of a trapezoid is equal to 1/2 the height, so h is your height, times base 1 plus base 2. So B stands for base. And there's two bases. So I recommend that you put this on your formula sheet and draw a picture for a reference. Okay? And know that B stands for the base and H is the height. And remember that height has to make a 90-degree angle in order for it to be considered the height. All right, let's do an example of the area of a trapezoid. So I have a decorative chest of drawers, and it looks like a trapezoid. If you want to draw this in your notes, I would just draw it as a trapezoid. I wouldn't necessarily draw it as a dresser, but you could just go ahead and draw a trapezoid and label the parts. And I want to know the area of the front of the trapezoid. So I want the area of just the front. So area of a trapezoid is 1/2 height times base 1 plus base 2. All right, so when I do that, I'm going to go ahead and plug in all the parts that I know. I know that the height is 20 inches because that's what drops down to make a 90-degree angle. Base 1 is 18 plus base 2 is 12. And now I'm just going to go ahead and do the math. Half of 20 is 10. And 18 plus 12 is 30. And 10 times 30 is 300. So this would be 300 units squared. And the units happen to be inches. So I'm going to say 300 inches squared. Okay, so that's an example of finding the area of a trapezoid. We're going to talk about a couple more areas here. So one is the area of a rhombus. So this is what a rhombus looks like. Remember, all sides are congruent. Okay, and we have two diagonals that make a 90-degree angle. And remember, the two diagonals are cut in half. Okay, so this segment, this half of the diagonal and this half of the diagonal are congruent, and same for the other two. And so the area of a rhombus is equal to 1/2 diagonal 1, so the whole length of diagonal 1 and the whole length of diagonal 2. So D stands for diagonal. And it doesn't really matter which one you label as diagonal 1 or diagonal 2. Okay, so I would put this in my notes on my formula sheet, and I would draw a picture as a reference. Area of a kite. Well, guess what? An area of a kite is the same formula as the area of a rhombus. So it's 1/2 diagonal 1 times diagonal 2. We know that this is a kite because it's got two congruent disjointed sides. Okay, and then again, D stands for diagonal, and it doesn't matter which one you put as diagonal 1 or diagonal 2. All right, so let's go ahead and use these two formulas and practice them. So the first one we're going to do is it says find the area of the rhombus or a kite. So the first thing you should always do is decide what the figure shape is. Even though the kite and a rhombus is the same, you know, I'm going to put a figure on your paper and you're going to have to be able to decide. So we know this is a kite because it has two adjacent congruent angles, okay? So, or congruent sides, excuse me. So these two sides are congruent and these two sides are congruent. And so we would say the area of a kite is equal to 1/2 diagonal 1 times diagonal 2. So we'll do 1/2 diagonal 1. Well, we'll say this is diagonal 1, 9 and 5 make 14. And then this would be diagonal 2. Remember the properties of a kite, that this diagonal is bisected. So it means both sides are congruent. So if this is 4, this is 4. So the diagonal 2 is 8. So half of 14 is 7, and 7 times 8 is 56. So this would be 56 units squared. Don't forget the squared when we're talking about area. Okay, the next figure, we know as we are looking at that is a rhombus. All sides are congruent, and the other thing that we know about a rhombus is that the diagonals are bisected. Both diagonals are bisected. So if this is 2.71 or 2.7, this is also 2.7. If this is 1.4, this is also 1.4. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2. We're going to do half of the first diagonal. The first diagonal will just go as 2.7 plus 2.7, which is 5.4. Diagonal 2 is 1.4 plus 1.4, which is 2.8. Half of 5.4 is 2.7, and 2.7 times 2.8 would be 7.56 units squared. Okay, so that's an example of a rhombus and a kite. Use the given information to find the value of x. So the first thing I want to do is find x. So it looks like I'm looking for this length right here. I know that this is a rhombus because all sides are congruent. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2. 1/2 of diagonal 1. Well, this is going to be our diagonal 1. And remember, if this is 15, then this is also 15. So diagonal 1 is 30. And diagonal 2 is, if this is x, then this is x. So diagonal 2 altogether is 2x, because x plus x would be 2x. So, and we know that the area is equal to 300. So I'm going to set that equal to 300 right away. So I've got 300, which is equal to half of 30, which is 15, times 2x. And if I simplify this further, 300 equals 15 times 2x, which is 30x. And to solve for x, I would divide by 30, and I would get x is 10. So x is 10 meters. Now remember, we were looking for a length, not an area, so we would say 10 meters. All right, let's try another one. Make sure that you're writing these down and getting them into your notes. Here I have a trapezoid. I know this is a trapezoid because we have two bases that are parallel. So our area is 39. So first, let's talk about the area of a trapezoid. It's 1/2 base, it's 1/2 height times base 1 plus base 2. So it's 39 equals 1/2 the height, which is 6. Base 1 is 9 plus base 2 is x. So I'll say 39 equals 1/2 of 6 is 3. And that's 9 plus x, as I'm going to bring that down. That's being multiplied. And to cancel out a multiplication, the opposite would be to divide. So I'm going to go ahead and divide by 3 on both sides. I get 13 equals 9 plus x. Subtract 9 from both sides, and I get x equals 4 centimeters. And remember, we're looking for a length, so we're just going to use centimeters. All right, so let's do one more problem. This time I have a figure that has multiple shapes inside of it. And so I'm going to first identify the shapes that I have. This shape here is a rhombus. So I need to find the area of the rhombus. And then this shape here looks like a parallelogram. And we've already found the area of a parallelogram in previous lessons. So to find the area of this whole shape or whole figure, my plan is to find the area of each individual shape, which is a rhombus and a parallelogram. The area of a rhombus is 1/2 diagonal 1 times diagonal 2 plus the area of a parallelogram. Remember, that's base times height. So as I go ahead and do this, I've got some missing pieces. So the first thing I'm going to do is I'm going to label all the parts. So everything that has 2 hash marks, I'm going to label as a 5. Everything that has a single, I'm going to label as a 4. Okay. And so what does that give me? I know that 1/2 diagonal 1, my diagonal 1 here looks like it would be 8. Diagonal 2, I don't know. Plus my base of my parallelogram is 4, but my height, I don't know. So I am missing a diagonal 2 and a height. So in order to get that, let's look at our diagonal here. This diagonal is making a 90-degree angle. Remember, that's what it does in a rhombus. And I know 2 of the sides. So if I have a 90-degree angle, I can use the Pythagorean theorem. So x squared plus 4 squared equals 5 squared. X squared plus 16 equals, sorry, I'm going to erase that little part there, equals 5 squared, which is 25. Subtract 16, I get x squared equals 9, square root both sides, x equals 3. So I know this is 3, that's going to tell me that is 3. So my diagonal 2 is actually 6. Now, if I want to find the height of my parallelogram, I drop a 90-degree angle. Again, I can use that 90-degree angle, which is the same as this one over here. So that must mean the height of my parallelogram is 3. So the area of the rhombus is 1/2 8 times 6, which is 4 times 6, which is 24. Okay, units squared. Plus 4 times 3 is 12 units squared. And I add those two together, and I get a total area for this whole figure to be 36 units squared. All right, that's the last example. Thank you, and we will begin practicing this tomorrow in class. That's all, folks. Have a great night.